screencast to show you how to create a graph with error bars that are 95% confidence intervals in Excel. If you were going on to graduate school or something like this, you're eventually going to learn how to do this in programs like R, but for the moment we're not going to teach you R, but you do need to be able to illustrate data appropriately, and so you can do this in Excel. You just have to have the summary statistics from your calculations that you made in class. So today we're going to be dealing with the plant growth data, which was the example that your lab instructor has worked through with you. So open up Excel, and what you need to do is start off with a category for treatments. So we had a control treatment, we had 2% glucose, we had 2% fructose, we had a 1% to 1% ratio of glucose to fructose, and then we had a 2% sucrose treatment, and this was the type of water that was given to the plants. And then all we really need after that is the average growth increment value, which is 70.1, 59.3, 58.2, 58, and 64.1. Then the last thing that we need is we need the width of the 95% confidence interval. And you calculated this when you were calculating the 95% confidence interval. This is what gets added to the mean and taken from the mean in order to know what the confidence interval, the width of the confidence interval is. And so you can go back and look at those calculations, and you should have 2.85, 1.17, 1.34, 1.01, and 1.28. Now, once you have that stuff, highlight the treatments and the means. Don't highlight the width of the confidence interval at this point. Go over to the Insert tab of Excel and choose a bar graph. And so we're going to choose a bar graph, and this will immediately show us what the means are for this particular data set. What it doesn't show you is it doesn't show you what the confidence intervals are, and that's what we need to add to this thing. And so we've got control with the highest, sucrose with the second highest, and then the glucose and fructose treatments are all lower than that. So click on any of the bars. So you'll see that when you click on them, it highlights them. And then go up here to the upper left, and it says Add Chart Element, and you want to add error bars. And when you look at error bars, it's going to show you can have none, you can have standard error, you can have percentage, you can have standard deviation, and it doesn't actually give you the option of customizing. So, but what you can do is you can click on the other. You saw that I clicked on error bars, more error bar options, and when you click on that, it has this pop-up that comes up over here, and what you want to do is you want to come down here and click Custom, because you want to specify the values, and you want the positive value, what it adds to the mean, to be in the positive error value, and you want the negative error value to be the exact same thing. And then when you click OK, you will see that it will add error bars, and those error bars are proportional to what you think the 95% confidence interval should be. The problem is that these figures are just defaulted with a blue fill color. So once again, you can click on these things and you can format the data series, and you can come here and you can basically change what color things are. So to go to the paint thing here, you can change the fill color. I would change it to white, and you can change the line color, and I would change that to black. And now you can actually see both sides of the error bars, and you'll see that they're symmetrical, which is what you should expect. But the other thing is you can't really see very well what the comparisons might be. So one thing that you can do is go over here and click on this. When you click on that, it'll show you formatting options, And if you change this to 55, what it will do is it will zoom in on that. So now the y-axis goes from 75 to, or 55 to 75, and now you can see the error bars in a little more detail. Last things that you need to do is obviously change this stupid title mean to something else, like growth increment of plants watered with different sugars, for perhaps that seems good. And then you can go and add a chart axis, like an axis title. You can do the primary horizontal axis, and this can just be something as simple as treatment. And you can add an axis title to the vertical axis, which is, essentially growth increment in millimeters. And so now that you have that, you can of course change the font size on any of this stuff by just going and clicking on it and changing font sizes. And you can pretty this up however it is that you want it to be. And before you know it, you have a figure that you don't have any problem presenting to someone. Once you have that, you should essentially take a picture of that or save this, and you can save it as a picture, and you can save it as a PNG. So we're just going to save it as plant growth, and I'm going to put it not in my pictures folder, but I'm actually going to put it in Dropbox in the 2024 section and in lab for week 3 statistics. And so I'm going to save it there. Once you've saved it there, go make sure that it actually is there before you close out of this. And so we'll go and look at that, and you should see that there's a PNG file there, and it should look like exactly what you did. And so now that you have that, you can now open up Word. And once you have opened up Word, make a new document. And in that new document, you basically want to insert a picture from File, go to wherever it is that you stored that in Lab in week 3, and there's the PNG. And then once you have that PNG in there, then you need to create a figure. And this is going to be figure 1 because it's the only figure that we have. And all figures have a figure number. They also have a title. So the title here might be growth increment in plants watered with different sugars. And that's the title, and you don't need a verb or anything in there, but this one happens to have a verb, but really it's a subject because that verb is within a prepositional phrase. So that's the title, and then once you have the title, then you need to offer some sort of explanation as to what the figure means. So we might say control pure water resulted in more growth than either sucrose or any of the simple sugars. Sucrose also exhibited higher growth than any of the simple sugars, but less than the control. Okay, so once you take care of all of your misspellings, well, I guess I should probably leave control capitalized. capitalize sucrose. And then the last thing that you might want to have in here is the statistical result that makes you think that this is okay. So you did an ANOVA on these data. The F statistic was 49 point something, if I recall correctly, 49.37, and the p-value is essentially much, much smaller than 0.001, because when you calculated the p-value using the SOPR website, you found that it was effectively 0, except when you do this for the F, you also need to put in the degrees of freedom, and the degrees of freedom in this case are 4 and 45 for the numerator and denominator, and we would usually put that as a little subscript to the thing. So when you get this thing all finished, you should have something that looks like this: a figure with 95% confidence intervals, so you can easily tell which means are different from one another, a figure caption that has a number, a title, and an explanation with a statistical justification as to why you are saying that these things are different. And so once you have that, save it as a Word file, then save it as a PDF, and then submit that PDF as a group to your lab instructor. And that's pretty much it.